So here we've got the area under a curve. So this is shouting out that it's going to be integration. However, I'm not just integrating and substituting in limits because I don't know what the second limit is. And the whole point of the question is to work out what a is. So I can write down an integral for my function. I know I'm integrating between 8 and a, and I am integrating 2x to the third minus, now I need to write this in just normal power form, so minus 7x to the minus a third with respect to x, and that is equal to 45. So I've set up an equation. It doesn't look particularly nice even from the start, and now I'm going to need to solve it. So what am I now going to do? I am going to put square brackets, and then I've got my 2x to the third, but I'm going to raise the power by 1. This becomes 4 over 3. And I divide by 4 over 3, which is the same as timesing by 3 over 4. I'm going to do as much as I can without a calculator here. Similarly, for the second one, I'm going to raise the power by 1. That's going to give me 2 over 3. I'm going to divide by 2 over 3, which is the same as timesing by 3 over 2. And I've integrated this function and I'm evaluating it between 8 and a again. Okay. What can I do? Well, first of all, I can just cancel this down a little bit. So it's going to become 3 over 2. And this is going to become 21 over 2. So substituting in for a, I'm going to get 3 over 2 a to the 4 over 3 minus 21 over 2 a to the 2 over 3. That's my first bit. Minus bracket 3 over 2 times 8 to the 4 over 3 minus 21 over 2 times 8 to the 2 over 3 is equal to 45. I think before I do anything else, I'm just going to simplify the 8's down. So I'm going to rewrite this. Minus, okay, 8 to the 4 over 3. You can just put this in your calculator, but what it's going to be is the cube root of 8, which is 2, then raise to the power of 4, which is 16. I'm then going to divide that by 2 to give me 8, and so I'm going to get 24. And then the cube root of 8 again here is 2. I'm going to raise that to the power of 2 for 4, and then I'm going to do 4 times minus 21 over 2, which is the same as minus 21 times 2, and I'm going to get minus 42, I believe. That is equal to 45. This thing here is, what's that equal to? That is equal to 18, minus 18 rather, so I'm going to put minus 18 here, and then I'm going to get, okay, don't do too much at once, 3 over 2, a to the 4 over 3. Yeah, this is fine. Sorry, I just thought I'd made a mistake then. Okay, so I'm going to get plus 18. Then I'm going to do 45 minus 18. And that's going to give me 27. I don't know why I did it on the right-hand side, actually. I think I'm going to be bringing it across, but hey, I've done that. Right, this, how are we going to solve this? Okay, let's just keep going. Let's keep simplifying it, and maybe we'll realize. So I would then get rid of the fractions by multiplying through by 2. And now I see there's a common factor of 3 in there as well. We can always try and simplify as much as we can. Sorry, I made a mistake there. A to the 4 over 3 minus 7 a to the 2/3. Divide 54 by 3, that's going to give me 18. I'm then going to bring it over. Why am I going to do that? Because this is actually a hidden quadratic. So I think I'm going to do a substitution here. U equals a to the 2/3, because then u squared is a to the 2/3 squared, which is a to the 4/3. You could immediately factorize it in terms of a to the 2/3. I just thought I'd go a bit slower, because this looks a lot nicer now. We can factorize this. U rather, and u here. Okay, I need one to be negative and one to be positive, so it's going to be -9 and +2. U equals 9 or -2. That's the solution to the quadratic. Let's get it back in terms of a. A to the 2/3 is then going to equal 9 or -2. Now we know that a is bigger, so just back to the start of the question, a is bigger than 8. So there's no way we could then raise it to the power of 2/3 and get a negative and make that work, so we can reject the -2. And what we're going to do then is we can basically, how I solve these is we can raise both sides to the power 3. Let's do it in steps actually. A squared is going to equal 9 to the power 3. And then we can raise both sides to the power of 1/2. And we can take the square root, and we know that a is positive, so we don't need to include the negative. So we're going to get that a is actually 9 to the 3/2. We put this in our calculator, or we can take the square root of 9, which is 3, raise it to the power 3, and we're going to get 27. That was not a very good 20, looks like 17. 27, which is the answer to this question. Whew, quite a lot to do, but hey, it is the last question on pure in this paper, and it's really testing our understanding of integration, algebraic manipulation, hidden quadratics, and all that.